Welcome to day 4 class of base SAS training. So today we'll be working on functions. So in the last class I've asked you to read around 9 to 10 chapters. So the very first thing which you would have read was about functions. So SAS has more than 400 functions. So it is not necessary that you will learn all the functions, and there is no use also to memorize all of them. You just need to understand the concept. Once you understand the concept, you'll be able to apply all the functions successfully. So now there are multiple types of functions. There are character related functions which can only be applied on character values, and there are numeric related functions which can only be applied on numeric values. Also, there are functions which can be applied both on character and numeric values. So we'll be working on all these functions today. Then we'll be learning about underscore error underscore n underscore, which are known as automatic variables. Then we will be learning how to concatenate two separate variables. Concatenation means joining two separate variables. We'll also be learning how to import a data from outside SAS into SAS environment. Then we'll also be learning about frequency. Frequency means how many times something has repeated itself. First, we'll be learning about one level frequency, then we'll do two level frequency. And finally, at the end of the day today, we'll be working on sorting our data. Sorting the data means arranging your data in ascending or descending sequence. We'll do one level sorting and then we'll do two level sorting today. So we'll start the class today. We'll first of all go and copy the codes. So here I am in the learning materials. We'll go to codes. We'll open SAS training basic. Today we'll be working on day 4 codes. So I'll control E to select all these codes and then copy all these codes, paste them in the program editor. So we'll be working on all these codes today. So we will start today with functions first. So if you remember, we have a data in the SAS user library by the name admit. So we'll create a copy of admit data again in the work library by the name admit. So we have done this. I'll select and run. I'll show you the log. It has created a copy in the work library by the name admit. So I'll open work. We have admit data. So we'll be using this data again to learn about functions and other things. So let's take a hypothetical situation here. Let's say that we know that there is a specific kind of disease which can only happen to individuals who have BMI, that is body mass index, which is less than 6. So now this is the data in front of you. Your manager asks you to work on this data, which is work.admit, and take out the details of individuals whose BMI, that is body mass index, is less than 6. So now a lot of people might get confused seeing this data here, because if you see, we have all these variables: name, sex, date, age, height, weight, all these variables. But we do not have any variable over here by the name BMI. So always remember, as a researcher, a person should understand that he or she becomes a researcher so that they can utilize the existing data that they have and convert it into the result that is required. So over here we are looking for BMI. So what exactly is BMI? BMI is actually the sum of height and weight divided by age here. So we have height, we have weight, and we have age. Rather than telling our manager that we can't work on this data because we don't have BMI, what we'll do is we'll create a new variable. We'll give the name BMI. On day 2 we learn how to create new variables. So we'll create a new variable by the name BMI, where we will add up height and weight and we'll divide it by age, then we'll get the BMI. Because see, as a researcher, you will never get everything in your data. If everything is already present in the data, then a researcher will never be hired in an organization. So a researcher uses the existing data that they have and convert it into the result that is required. So to do that, to get the sum of height and weight divided by age here, we use functions for that. So let's close this. I'll show you how it's done. So I've created a new data, admit2. I'm picking it up from admit data. Automatically both will be created and picked it up from the work library because we did not mention the name of the library. So I've created a new variable here by the name BMI because anything before the equal to sign is the name of the variable. So I've just given the name of the variable here BMI because we're looking for BMI. Otherwise, you can give any name. Let's say instead of BMI here, we'll write XYZ. You can give any name as long as it follows the rules, which is 1 to 32 characters, can have an underscore, cannot start with a number, cannot have spaces, and cannot have special characters. So I've created this one new variable here by the name XYZ. XYZ is actually BMI, that is body mass index. So what I'm doing over here is I'm using a sum function here. Sum function open bracket height comma weight. This will give me the sum of height and weight. Now whatever the sum of height and weight is will be divided by age here. The reason I'm mentioning in brackets here is due to the rule of BODMAS, so that it first add up height and weight, then it will divide it by age. So we're getting a new variable here by the name XYZ. In admit data we have 9 variables. Now if I add XYZ, so in admit 2 we'll have a total of 10 variables created. So I'll select and run. I'll show you the log. We have 10 variables created in admit 2 data. Now I'll open admit 2. Here we have added XYZ, which is BMI. Here I can easily give XYZ is greater than 6 or less than 6 and I can easily get my answer. Alright, now if you see this XYZ variable, it's in a lot of decimal places. So one way to remove these decimals here is I can use another function in the command. This time I'll use a round function here. So we'll run this command again. We'll overwrite admit 2. Let's say this time instead of XYZ here we'll just write BMI because we're looking for BMI. So this time whatever the sum of height and weight divided by age will be rounded up. I'll select and run. We'll have again 10 variables in admit 2 data because we have just overwrite the same data. So I'll open admit 2. Here we have BMI instead of XYZ, which is a rounded value. Here I can easily give BMI is greater than 6 or less than 6 and I can easily do data mining here. Alright, so now if you remember the rule says every command should begin with a keyword, either a data or a proc keyword. And every command should end with a run command here. So one way after this run command here is I can start writing the command again. I can start with a keyword and then I'll mention where to create this data. I'm gonna create in admit 2. Then I'll mention where to pick up this data from, and then I'll add these new variables and I'll mention a run command. That is one way the command will be complete. The other way is because we are practicing here. So what I'll do is I'll just remove the run command from here because we have already started with a keyword here. I've mentioned where to pick up this data from. I'm just adding these new variables to the same admit 2 data. And I've mentioned a run command here. So if I select the entire thing, the command will be complete, so that I don't have to write data set admit again and again. And remember, SAS statements are free format statements, which means I can give any amount of space here. As long as I select the entire thing, the command will be complete. So it doesn't matter if I leave this one space here also. So earlier we did the sum of height and weight divided by age, we got BMI. Now let's say this time we have to add multiple variables together this time. Let's say we have to add age, date, height, weight together all at once. So one way you can do that is like how we did earlier. We'll do sum function open bracket height comma weight comma, then we'll do age comma date comma. That is one way we will get the sum of age, date, height, weight all together. The other way is, let's say we have a very big data here and you want to add multiple variables together. Let's say you have to add around 20 to 30 variables all together all at once. Now if you have to mention each name of the variable name that you want to add, around 20 to 30 of them, then that would take you a lot of time and a lot of work. So in this case, what we'll do is we'll write a command in such a way where we will not have to do that. to write each name of the variable name that we want to add. So what we'll do is we'll just write the first name of the variable name that we want to add. In this case, age. Then we'll give a double dash or a double hyphen. And then we'll write the last name of the variable name that we want to add. In this case, weight. So a double dash or a double hyphen, what it will do is it will calculate all the numeric value that is in between the first and the last variable that we have mentioned. So this way, I don't have to write every numeric variable name that I want to add. If I do each double hyphen weight, it will automatically add each date, height, weight together, which means in the first observation, it will automatically add 27 plus 1 plus 72 plus 168. That is the function of a double dash or a double hyphen. Now let's just say in between age and weight variable, there is a character variable in between, such as name or sex. So when I use a sum function will not add characters because we cannot add 27 plus m plus Murray will not get the answer. So a sum function will not add characters, will neither give you an error. What a sum function will do is it will simply calculate just the numeric value that is in between the first and the last variable that we have mentioned. And that is one reason also why we prefer a sum function over an operator sign, such as a plus sign. Now I'll just show you an example. Let's say we have done a survey, and in this survey here we have inquired prices. Let's say here we have price of item A, and in this other column we have price of item B. So now I'll just type some random prices here, random numbers. Let's say we have inquired all these price here, and let's say someone did not mention about their price, so we'll just leave it as not applicable, which means there is a character in between. Here also someone did not mention, so we'll just leave it as not applicable. So I'll just use a sum function here, and over here I'll use a plus sign. Let's see what difference does it make when we use a sum function over a plus sign. To use a sum function here, we'll just write equal, we'll write sum, we'll open bracket, click on the first column that we want to add, drag it to the next column, close the bracket and press on enter. Now if you do 65 plus 43, you'll get this answer. Now to do the same for the rest, I'll just drag it down. It will automatically add the rest. Now because there is a missing here, so it has just taken 43. Here also there is a missing, it has just taken 45. This plus this is 110. Now let's see what happens if we use a plus sign here. To use a plus sign, we just write equal, open bracket, click on the first column that we want to add, put on a plus sign, click on the second column that we want to add, close the bracket and press on enter. Now again, if you do this plus this, you'll get this answer. Now to do the same for the rest, I'll just drag it down again. It will automatically add the rest. So now this is the reason why we use a sum function over an operator sign, because a plus sign, if it sees a character in between, it will not give you the answer. Whereas a sum function just considers the characters as 0, simply calculate just the numeric value that is in between the first and the last variable that we have mentioned. So that is the reason why we use a sum function over a plus sign. Alright, so we have this variable here by the name fee. Now let's just take a scenario here that fee is the insurance amount which everybody has to pay. So in America, it is possible to pay $85.20. In Europe also, it is possible to pay 85 euros and 20 cents. But in India, it is not possible to pay 85 rupees and 20 paisa. It is neither possible to pay 124 rupees and 80 paisa because we don't have paisa anymore. So either you pay 85 rupees or 86 rupees here. So what has to be taken by an organization? Because if an organization takes 86 rupees from you, you will not complain because it is just 80 paisa more. Or if an organization takes 85 rupees also, it will not make such of a difference to you as it is only 20 paisa more to you. But it does not work like that if you're working in an organization. Majorly, there are a lot of researches which happen behind it to understand whether an organization should take an upper value or take the lower value. Because let's say companies like LIC, they quoted that their organization has more than 100 crore policies. So if from every person they take 20 paisa less, they will be suffering a loss of 20 crore. And just by taking 80 paisa more, they will be gaining a profit of 80 crore. And 80 crore is a very big amount. So just by giving this example also, it is not necessary that an organization should take an upper value or take the lower value. There are other factors behind that and proper research is done on that. But just to convert this into the upper value or the lower value, there are functions for it in SAS. So if we build a house, we do need to have a ceiling above our head and a floor. So similarly, there are functions which is known as a ceil function and a floor function. If I apply a ceil function against this variable phi, it will give me the upper value of phi. And when I use a floor function against this variable phi, it will give me the lower value of phi. So let's see how do we do that? How do we add multiple variables together and get the upper value or lower value of phi? So I'll close this. I'll come to the program editor. So earlier I've just removed the run command because I'm just adding new variables to the same admit2 data. So I've created a new variable here by the name ABC. I'm using a sum function here. Open bracket off. Off is written now because I'm adding multiple variables together now. Sum of each double hyphen weight. So which means from each till weight, whatever numeric variable there is in between, it would be added. And then a semicolon because every statement should end with a semicolon. So I've created a new variable by the name phi2. I'm using a ceil function here against variable phi. This will give me the upper value of phi. Phi3 is just a new variable name. You can give any name. I'm using a floor function against variable phi. This will give me the lower value of phi. So now if we see here, all these sum, ceil, floor, round, all these are functions that I'm using here. So earlier we added BMI, we got 10 variables. This time we're adding 3 more variables, so we'll have a total of 13 variables created in admit2 data. We have 13 variables in admit2. I'll open admit2. We have added EBC, phi2 and phi3. Now EBC is sum of each double hyphen weight. If you do 27 plus 1 is 28, plus 72 is 100, plus 168 is 268. Similarly for the rest as well. Phi2 is a ceil function against variable phi. 85.20, it has given us upper value 86. 124.80, upper value 125. Phi3 is a floor function against variable phi. 85.20, lower value 85. 124.80, lower value 124. So now let's say you want to take out the square of something here. Let's say you want to take out the square of height. So we can do height into height. And let's say you want to take out the square root of weight. So we can use functions for that. So let's see how do we do that. So I'll close this, come to the program editor. Again, I'll just remove the run command here because I'm just adding new variables to the same admit2 data. So I've created a new variable here by the name HEI. HEI is just short for height. You can give any name because I'm doing height into height here. This will give me the square of height. SQR is a new variable name. This is just short for square root. So in mathematics, if you want to take out the square root, you do the under root sign and take out the square root. But in SAS, we just write SQRT, which is a function here. This will give me the square root of weight. LG is a new variable name. I'm using a log function against variable h. This will give me the log value of h. Earlier, we added 3 variables. We got 13 variables. Now we're adding 3 more, so we'll have a total of 16 variables created in admit2 data. We have 16 variables in admit2 data. So I'll open admit2 data here. We have added HEI here, which is square of height. If we do 72 into 72, we'll get this answer. SQR, which is square root of weight. And LG, which is log value of each here. Alright, now the next function that we will look at is called a minimum and a maximum function. A minimum function will give you the minimum value and a maximum function will give you the maximum value. So a minimum and a maximum will work like this horizontally. For example, if I want to check the minimum, let's say between height and weight, then in the first observation, minimum will give me 72, second observation 66, third observation 61, minimum between height and weight. If I want to see the maximum between height and weight, then in the first observation it'll give me 168, second observation 152, third observation 123, maximum between height and weight. Here also, if you want to see the minimum or maximum between multiple variables, you can do each double hyphen weight here. It will give you the minimum or maximum between multiple variables here. So let's see how do we use a minimum and a maximum function here. So again, I'll just remove the run command. So I've created a new variable mn, which is short for minimum. You can give any name. So I'm using a minimum function here. Open bracket height comma weight. This will give me the minimum between height and weight. Mx is a new variable name. I'm using a maximum function. Open bracket height comma weight. This will give me the maximum between height and weight. Earlier we got 16 variables. Now I'm adding 2 more, so we'll have a total of 18 variables created in admit2 data this time. So we have 18 variables in admit2, so I'll open admit2. Here we have mn, which is minimum between height and weight, and mx, which is maximum between height and weight. So what we have learned till now is these are just a few examples of numeric related functions here. There are a lot of other functions which can be applied to numeric values, such as integers and a lot of other functions. But I've just given you a few examples here so that by now you understand how to utilize a function. So now we will move ahead. Now we will learn about character related functions, functions that can be applied on character values. So we have admit data here. So I'll open admit data. So in this admit data, we have this name variable. Now name is a character variable. So if you see in this name variable, in every observation, every name is written in a normal way. For example, it starts with a capital letter and then follows small letters, and then the last name again starts with a capital letter again, just like how we learn in school. So now let's say I want to see all these letters here to be in capital letters, or I want to see all of these in small letters here. So in this case, we will use functions which are used against character values. We'll use either an uppercase or a lowercase function here. So let's close this data. Let's see how do we use functions that are used against character variables. So I've created a new data by the name admit3. I'm picking it up from admit data. Automatically both will be created and picked it up from the work library because we did not mention the name of the library here. So I'm creating a new variable by the name name2. I'm using an uppercase function against name variable. This will give me the uppercase of all the names. Name3 again is a new variable name. I'm using a lowercase function this time against name variable. This will give me the lowercase of all the names. So this time I'm creating a new data admit3. So we're reading from admit data again. So in admit data we have 9 variables. Now we're gonna add name2 and name3. So we'll have a total of 11 variables created this time in admit3 data. I'll open admit3. Here we have added name2 and name3. Name2 is uppercase of all the names, all the capital letters. Name3 is lowercase of all the names, small letters here. Alright, so again in this name variable here, if you see, every name here has characters. Now let's say I want to find out the length of every character of every name here. So there is a function which is known as a length function. When I use a length function here against this name variable, it will give me the length of all the characters, which includes spaces and special characters. For example, if you see this first name here, we have Murray, there's a comma and a space and then W. So when I use a length function here, it will calculate all these characters which include spaces and special characters here. For example, in this name variable, it will give me MURRAY, which is 6, comma will be 7, space will be 8, W will be 9. The total length for this Murray, comma, space W will be 9. Similarly, for Almers also, it will give me ALMERS, which is 6, comma again will be 7, space will be 8, C will be 9. So the total length for this name also will be 9. So that is what the length function does. It will give me the length of all the characters, which includes spaces and special characters here. Now there is another function which is known as a scan function. A scan function is used for scanning. For example, in this name variable, every name we have first and last name of every name here. Now the last name in every name is just the initials because identity of the patient should not be disclosed. So we have first and last name in every name here. So now let's say this time you only want to take out the first name from every name here. So in this case, I will use scan function here. I will do comma 1. Comma 1 will scan from left to right. For example, in this name here, Murray, if I use scan function comma 1, it will scan from M and it will stop scanning at Y here. Why? Because scanning stops as soon as it encounters a space or a special character. So after Murray, there is a comma and a space, so it will stop scanning here. So it will just take out this first name from here. Similarly, here also it will scan from A and it will stop scanning at S because it will stop scanning as soon as it encounters a space or a special character. So it will just take out the first name from every name here because after every first name there is a comma and a space, so scanning will stop. Now, if I want to take out just the last name from every name, then in this case I will use a scan function here. I'll do comma -1. Now -1 will scan from left to right. In this case, it will scan only W here because before W there is a comma and a space, so scanning will stop. Here also it will just scan C because before C there is a comma and a space, so scanning will stop. So it will just take out the last name from every name because before every last name there is a comma and a space, so scanning will stop. So that is the length function and a scan function. So let's see how do we use these functions here. So I'll close this data. I'll come to the program editor. Again, I'll just remove the run command from here because we are again just adding new variables to the same admit tree data. So I've created a new variable here by the name len. You can give any name here. This is just short for length. I'm using a length function here against name variable. This will give me the length of all the names, which includes spaces and special characters. Fname again is just the name of the variable, which is short for first name. Because I'm using a scan function against name variable, I'm doing comma 1. Comma 1 will scan from left to right. Lname is short for last name, is just the name of the variable. I'm using a scan function against name variable, and this time I'm doing comma -1. -1 will scan from right to left. Earlier we added name2 and name3, we got 11 variables. Now I'm adding 3 more variables. We'll have a total of 14 variables added to admit tree data. So we have 14 variables in admit tree. So I'll open admit tree here. Now we added length, fname and lname. Here, if you see, the length of all the names has come. Now the length function has also calculated spaces and special characters. If you remember earlier when we counted Murray with the comma and a space, the total length was 9. Here also the length is 9. Almus also with the comma and the space, the total length was 9. Here also is 9. So it has given us the length of all the characters, which include spaces and special characters. Now if you see carefully in this length variable here, the highest length here is this 14. There is no length beyond 14 here. That is because this name Bonaventure is the name with the highest length, 14. And that is the reason also on the very first day when I double clicked on name variable, it was showing us $14 dot. 14 here, it was taking automatically the highest length for this name here, Bonaventure, which is the highest length. And then we have first name here. We did scan function. We did comma 1. Comma 1 has scanned from left to right. So if you see, it has just scanned the first name from every name because after every first name there is a comma and a space. So scanning has stopped. And then we use scan function comma -1. -1 here has scanned from right to left. In this case, it has only scanned the last initials only because In every name, before every last initials, there is a comma and a space, so scanning has stopped. Alright, so the next function that we will look at is known as a count function. As the name suggests, it counts how many times something has appeared. For example, in this name variable here, let's say in every name here, I want to count how many times small a has appeared in every name. For example, in this first name here, if you see, small a has appeared one time, so the count here will be 1. Here there is no small a, so the count will be 0. Here small a has appeared one time, so the count will be 1 again. Here there is 2 small a, now the count will be 2 here. So that is what the count function will do. It will tell you how many times something has appeared. Now the next function is called index function. For example, when we search for something, we do Ctrl F and it shows us where something is located. It highlights in which page it is located in. So similarly, index function also will tell you in which location it is located. Let's take for example, in every name here, I want to find out the positioning of small a in every name. So if we see here in this first name here, the positioning of small a is in the 5th position. If you count MURR, that is 4, small a is in the 5th position. So index here will be 5. Here there is no small a, index will be 0. Here small a is in the 4th position, so index will be 4. Now there are 2 small a's here. Now index will only give you 2 because it will only tell you of the first encountering of small a, which is in the 2nd position. Now that is index function. Then we have another function called substring function. Substring is substitute of a string. For example, in this name variable here, every name is a character and every character is a string. Like for example, this name Murray, comma, space, W, all these are strings. Almus, comma, space, C, all these are strings which include spaces and special characters. So let's say this time I only want to take out the strings of the first 3 letters only from every name. So I will use substring function here. I'll do 1 comma 3. Now 1 comma 3 will take out only letter 1, letter 2, letter 3 from every name. For example, here it will only take out MUR, only ALM. Here only BON. That means substitute of a string, you just take out the strings which you require. So let's see how do we use substring, index and count function here. So I'll close this data, come to the program editor. Again, I'll just remove the run command because again we're just adding these new variables to the same admit3 data. So I've created a new variable sub. I'm using substring function here. This is the substring function substr. I'm using the substring function against name variable, and here I'm doing 1 comma 3. 1 comma 3 will take out strings from 1 to 3. Let's say instead of 3 here we'll write 4, so it takes out strings from 1 to 4. ind is a new variable name. I'm using an index function against name variable. Now I want to find out the positioning of small a in every name. Cn is a new variable name, short for count, because I'm using a count function against name variable. And this will tell me how many times small a has appeared in every name. So earlier we got 14 variables. Now I'm adding 3 more, so we'll have a total of 17 variables created in admit3 data. I'll open admit3 data. Here we have sub, which is substring function. We did 1 comma 4, so it has taken out 4 strings from every name. ind tells you the positioning of small a in every name. So in the first name Murray, we see the positioning of small a is in the 5th position, so index is 5. Here there is no small a, index is 0. Here small a is in the 4th position, index is 4. Here there is 2 small a. Now index is giving you 2 because it will only tell you of the first encountering of small a, which is in the 2nd position. Here also we have 3 small a. Now index will give you 2 because it will only tell you of the first encountering of small a, which is in the 2nd position. Now Cn tells you how many times small a has appeared. In Murray, small a has appeared 1 time, so count is 1. Here also small a has appeared 1 time, count is 1. Here they are 2 small a, now the count is 2. Here they are 3 small a, now the count is 3. Alright, so the next function that we will look at now is called translate function. The way we have a replace function in our Word file, if we want to replace something, we do Ctrl R and we replace words there with new words. So in SAS, replaced is used for something else, but for similar tasks, we use a translate function. For example, in this name variable here, we see we have people that have small b in their names. If you see, we have small b in the name. Here also we have small b in the name. Now let's say wherever there is small b in the name, I want to translate it to a different letter, different alphabet. So this is where we'll use translate function. So let's see how to use translate function here. So I'll again just remove the run command. I've created a new variable, new underscore name. You can give any name. I'm using a translate function against name variable. Now whatever you have to translate to, you write it first, and whatever needs to be translated, you write it second. So I'm gonna translate in this name variable to capital Z wherever there is small b in the name. And I've mentioned in quotes here because these are characters, case sensitive. So earlier we got 17 variables, now I'm adding one more, so we'll have a total of 18 variables created in admit tree data. I'll open admit tree. Here we have new underscore name. Anywhere there is small b in the name, we have translated to capital Z. Alright, so that is translate function. And again, these are few examples of character related functions here. Now we will move ahead. Now we will learn about concatenation. The spelling of concatenation is concatenation means joining two separate variables. So I'll open admit data here. Now if you see in this admit data, we have all these variables: ID, name, sex, age, date, height. All these are separate variables, separate columns. Now let's say I don't want to see these variables separately here. I want to see some of them under one column. For example, I want to see sex and age variable under one column. As of now, they are separate variables, separate columns. Now I want to see them under one column. For example, M and 27 together, F and 34, F and 31 under one column, not separate columns like this. So this is where we will do concatenation here. So I'll close this data. Let's see how do we use concatenation. So concatenation is done by these parallel lines here. You'll find this parallel line in your keyboard. It will be just below the backspace or somewhere close to the enter key. So I'll just show you an example here. This is an on-screen keyboard. So this is a parallel line we are talking about. Now this parallel line, it's with the backslash. Now if I just press this, you'll only get the backslash. So to get the parallel line, you have to press shift and this key at the same time. You can try that in your keyboard. Shift and this key at the same time. So this is a piper here in SAS. We call this a piper here. So now whatever variable you write on the left and whatever variable you write on the right, both will get concatenated because of this piper. So I've created a new data here by the name admit4. I'm picking it up from admit data. I've created a new variable sex underscore age. You can give any name. I'm just giving sex underscore age here because I'm gonna concatenate sex piper age here, sex and age variable. So in admit we have 9 variables. Now I'm adding one more variable, so we'll have a total of 10 variables in admit4 data. I'll open admit4. Here we have added sex underscore age variable. Now here we have concatenated sex and age variable together. M and 27 now they're together, F and 34, F and 31, similarly for the rest as well. So this is concatenation. We have concatenated 2 columns here. So now if you see in between M and 27, F and 34, F and 31, there is a lot of spaces in between. So now let's say you don't want to have all these spaces in between. You want to remove the spaces here. So let's see how do we do that. So I'll close this. I'll come to the program editor. Again, I'll just remove the run command again because I'm just adding new variables to the same admit4 data. So I've created a new variable sex underscore age1. So first of all, this sex will concatenate with this age variable. sex piper age. Now whatever space there is in between, it will be compressed. Now this compressed is a function which is used both against character and numeric variable. So I've added one more variable this time, so we'll have a total of 11 variables created in admit4 data. Now I'll open admit4. Now we have added sex underscore h1. Here we have compressed all the space in between. Alright, so now if you see M and 27, F and 34, F and 31, they're too close together. Now let's say this time you don't want to see it like this. This time you want to see at least a comma separated value in between, like M, 27, F, 34, F, 31. So let's see how do we do that. So I'll close this. I'll come to the program editor. I'll remove the run command again. I've created a new variable sex underscore h2. So now there are three things here. First of all, this sex will concatenate with this comma. I've given this comma in quotes here because it's a special character. And this comma will concatenate with this each variable. Now whatever space there is in between, it will be compressed. I've added one more variable this time, so we'll have a total of 12 variables created in admit4 data. I'll open admit4. Here we have added sex underscore h2. Here we have just a comma separated value in between, like M, 27, F, 34, F, 31. So now let's say this time also, here you don't even want to see it like this time. Let's say this time you want at least a space in between instead of the comma. Not a lot of space like this, but just a single space instead of the comma. So a lot of people will say that instead of this comma, they'll just leave a blank here. So they are half correct. I'll tell you why, because if you see outside here, we have written compress. So if it can compress a lot of space, it can also compress this one space here. So in this case, what we'll do is we'll not use a compress function this time. This time we'll use another function called combl. The full form is compress and keep the blank. So this sex will concatenate with this blank. I've given this blank in quotes because it's a special character. And this blank will concatenate with this each. Whatever space there is in between, it will be compressed, but keep this one blank only. So I've added one more variable this time, so we'll have a total of 13 variables created in admit4 data. I'll open admit4. We have sex underscore h3. Here we have just a space in between. So we went from here to compressing all the space to a comma separated value in between and to just leaving one space in between. So that is concatenation. So now we will move ahead. So earlier we saw in admit3 data that in this name variable, the highest length in this name variable is 14. There is no length beyond 14 here because this name Bonaventure is the name with the highest length, which is 14. And then we also learn about substring function. Substring function gives you substitute of a string. Earlier we did 1, 4, so it has taken out 4 strings from every name here. Now let's say this time I use substring function this time against name variable again. This time I use substring function 20, 30. So what do you think the answer will be? Because if you see already in the name variable, there is no length beyond 14 here. So let's see this time what will happen if I use substring function 20, 30 this time. So I'll close this. I've created a new data, admit6. I'm picking it up from admit data. I've created a new variable sub. I'm using the substring function again against name variable, but this time I'm doing 20, 30. Now we already know there is no substring beyond 14 in the name variable. So let's see, I'll select and run. I'll open admit6 here. Now if you see, we have created this variable. Now here it is giving us the complete name as it is. Now this is just telling us that there is no substring in this name variable from 20 to 30. It has given us the complete name just to tell us that there is no substring from 20 to 30. Alright, so now I already know that in this name variable, there is no substring from 20 to 30. There is no strings beyond 14 here. The only reason I did substring 20, 30 is just because I wanted to show you the log window. Otherwise, I wouldn't do that command. So now I'll show you the log window. I'll close this. I'll show you the log window. So we did this in the program editor. We got all of this in the note here. So now you had read about automatic variables. Automatic variables are variables which are running at the back end of the SAS system. We do not create it, it is automatically created. Automatic variable starts with an underscore, ends with an underscore. For example, underscore error underscore underscore n underscore. These are automatic variables here. So now underscore error underscore is a binary version here. If underscore error underscore is equal to 1, that means there is an error. If underscore error underscore is equal to 0, that means there is no error. So here underscore error underscore is equal to 1. That is because this Murray doesn't have substring from 20 to 30. So there is an error with that name. Here also underscore error underscore is equal to 1 because Almus doesn't have substring from 20 to 30. Similarly, here also underscore error underscore is equal to 1 because Bonaventure doesn't have substring from 20 to 30. So with every name there is an error because we're doing substring 20 comma 30. So in every name there is no substring from 20 to 30. So that is why there is an error with every name. Now underscore n underscore will tell you which line or observation it is reading from. Here underscore n underscore is equal to 1. That is because it is reading Murray from the first observation in the data. Here also underscore n underscore is equal to 2 because it is reading Almus from the second observation in the data. Here underscore n underscore is equal to 3. That is because it is reading Bonaventure from the third observation in the data. So it is telling you from which line or observation it is reading from every name. And with every name that it read, there is an error with the name because we are doing substring 20 comma 30. So that is underscore error underscore and underscore n underscore here. Now I'll just show you another example of underscore n underscore because we sometimes use this in a data. So I've created a new data, admit 7. I'm picking it up from admit data. I've created a new variable EBC. I'm doing underscore n underscore here. Now this will tell us the number of observation it is reading from. I'll select and run. I'll open admit 7 here. We have created this ABC variable. Here we have all these numbers, which means Murray is in the first observation, Almus is in the second observation, Bonaventure in the third observation, all the way to 21 here. So now a lot of people looking at this data here will say that they can also see this number from this column here. Now I'll tell you why we cannot rely on this column if we want to know the exact position of an observation, because if you see on top of this one here, there is nothing written, neither serial number, text number or ID number. And whenever we talk about this data, we always talk about 21 observations and 9 variables here. We never consider this column here. So that is why we cannot rely on this column. If you want to know the exact position of an observation, you have to do underscore n underscore for that. Because let's take for example here, let's say in this data, I only have to work on this last observation only, whose ID is 2595. Let's say I only have to pick up this data only. So now if you see here, this observation, this is telling us it's in the 21st observation. Similarly, underscore n underscore tells us it's in the 21st observation. Now let's see what happens if I only pick up this data only. ID is 2595. Now ID, if I double click, the backend coding has a dollar sign, so which means it's a character variable. So to specify observations within character variable, we have to mention in quotes. So I've created a new data, admit 8. I'm picking it up from admit data. I'm using a where condition. I'm saying wherever in this ID variable is equal to 2595. So it will only pick up ID 2595. I'll select and run. I'll open admit 8. Here we've only picked up ID 2595 here. Now if you see now, this is telling us that it's in the first observation. Whereas in admit 7, it was telling us that it's in the 21st observation. So that is why if you want to know the exact position of an observation, you have to do underscore n underscore. Because let's say for example, this data this time, I pick it up from admit 7 here, where we have done underscore n underscore. I pick it up from admit 7. I'll select will override admit 8. So I'll open this. Now if you see, this is telling us that it's in the first observation, whereas underscore n underscore tells us it's in the 21st observation. So underscore n underscore will tell us in the entire data which position your observation lies in. So that is underscore n underscore. So now we will move ahead. Now we will learn how to import a data. So we have a file in the learnings folder. We said we normally use these files in the class when we learn about importing. So today we're gonna import this Volters here. Now this Volters is in my computer here. We will learn how to import it into SAS here. So to do that, we have to run a proc command. So we write proc import data file is equal to, you mention the part where this file is located. So I'll show you how to do this part. Then you mention the name of the file that you want to import. We're going to import that Volters data. So I mentioned the name of the file, Volters. So now we always import in Excel format. So the extension for Excel is XLS. The part has to be in single quotes. Now if you notice here, I did not specify semicolon here nor here, because this is all in one single statement here. I'll just do this. I'll keep it in one single statement for now. So we write proc import data file is equal to, you mention the part where this file is located. You mention the name of the file that you want to import, the extension of the file. The part has to be in single quotes. Now to create a data in a proc command, we have to specify an out command, which means when I import this Volters data, I'm going to save it in the work library by the name Rx. You can give any name, semicolon, run, semicolon. Now I'll show you how to do this part here. Now this file, you can find it in the learnings folder. It's the last one here. So this is an Excel file. So I'll open this. This is an actual data here. In this data, we have 8 variables, 8 columns, and we have around 65,000 plus observations here. And Volters has multiple sheets as well. If you see down here, we have sheet 1, sheet 2, sheet 3, and a data sheet. So I'll close this. So to import this file here, I have to copy the part from here. You just single click on top here. This part will be highlighted automatically. So you copy the part and then we'll paste this part in the program editor. So you paste the part within quotes from C till learnings here, because this will be the name of the file. This will be the extension of the file. So I'll select and run. I'll show you the log. The log says work.rx was successfully created. So I'll open rx data here. Now if you see, I did not import the data yet. Now I'll tell you why. Because if you remember that Volters has multiple sheets, sheet 1, sheet 2, sheet 3. So we need to specify which sheet to import. That is the reason it did not import the data. So everything else is the same here as the previous command. The only difference now is that I specify the name of the sheet. I'm going to import sheet 1 in quotes, semicolon, run, semicolon. I'll select and run. Now I'll show you Rx data. Now if you see, still we haven't imported the data yet. I'll tell you why this time. I'll show you the log. I'll read this note here. Import cancel. Output dataset work.rx already exists. Specify a replace option to overwrite it. So normally in a data command, if we give the same name of the data, it will overwrite the data. We've already created admin 7 here. If I give the same name, it will automatically overwrite this data here. But in a proc command, while importing and exporting, if you give the same name, we already created by the name work.rx. Now we're giving the same name here. So importing and exporting cannot be done. So you either have to change the name of the data or specify a replace option to overwrite it. So this is the main command here. I was showing you one by one because I want you to understand. So first of all, if the file has multiple sheets, if you do not mention the name of the sheet, it will not work. And in a proc command, while importing and exporting, if you give the same name, importing and exporting cannot be done. So we either change the name of the data or specify a replace option to overwrite it. So everything else is the same here. The only thing is that I want to save it by the same name. So I specify a replace option to overwrite it. So I'll read this command here. Proc import data file is equal to, you mention the path where this file is located, you mention the name of the file that you want to import, the extension of the file, and the path has to be in single quotes. Out is equal to work.rx, replace semicolon, sheet is equal to sheet1 in quotes semicolon, run semicolon. So I'll select and run. This is the main command here. So I'll show you the log. It says work.rx was successfully created. Now I'll open Rx here. We have successfully imported the file here. We have 8 variables, 8 columns, and we have 65,535 observations. So now the very first thing what any researcher, what he or she has to do is they first need to check what is present in the data. Once they know what is present in the data, only then they will be able to do a research on that. So to check what is present in the data, on day 2, I taught you that was proc contents. So I'll read this command here. Proc contents data is equal to rx semicolon run semicolon. So now this is a proc command here. I did not mention an out command, so a separate data will not be created. It's a simple proc command. This will only give me the contents of rx data. Automatically it will read rx from the work library because we did not mention the name of the library. So it will only give me the contents of rx data in listing and HTML format. I'll select and run listing and HTML. This is the contents procedure of work.rx. This number of observations, 65,000 plus observations. This number of variables, 8. And all the name of the variables here have come in alphabetical order. P, Q, S, T. Actually, in the data, it's coming in numerical order. First comes CID, second comes YRMO, third product, fourth. I'll show you in RX data. It's showing in numerical order. CID, YRMO, product. Now, if you want to see in the order that's mentioned in this data, then we will have to do this command here. I'll read this. Proc contents data is equal to rx varnum semicolon run semicolon. So varnum means variable in number order. So this will give me the contents of rx data in listing and HTML format, and this time in varnum order would be created. I'll select and run listing and HTML, the contents procedure of work.rx. This time the variables have come in number order, in the order that's shown in the data. Alright, so that was proc contents. Now we will move ahead. Now we will learn about frequency command. Now frequency means how many times something has repeated itself. For example, we have this Rx data here. In Rx data, we have this variable YRMO. YRMO is short for year month information. Because if you see here, we have a lot of year month information here. 2005-01, which means 2005 January, 1006 10. A lot of these year month information have been repeated here. So now let's say you want to check the frequency of this data here. You want to check the frequency against this variable YRMO. You want to see how many times these year month information have repeated here. So one way you can do that manually from this data here. You can start counting one by one. That would take you a lot of time and a lot of work. The other way is we can just use frequency command for that. So let's see how do we use a frequency command for that. Whenever we use a frequency command, we write proc frec. Though we call it frequency, but we write it frec. And to specify variables in frequency, we mention tables. Tables means variables. So I'll read this command here. Proc frec data is equal to rx semicolon tables YRMO semicolon run semicolon. Now again, this is a proc command here. I did not mention an out command, so a separate data will not be created. It will only create listing and HTML for the frequency of Rx data against this variable YRMO. So I'll select and run. Automatically it will take us to the listing and HTML. So automatically when we run the frequency procedure here, we automatically get frequency percent, cumulative frequency, cumulative percent here. Which means this variable YRMO 2005-01 has repeated 1702 times in the data. 2,502 has repeated 408 times in the data. 2,503 47 times. All these year month information, it has tell us how many times it has repeated in the data. So now it might be a possibility here that you might get confused seeing this data because this is a very big data here. So what we'll do is we'll show you with a smaller data here. We have admit data. In admit data, we have the sex variable. In sex variable, we have M and F repeated here, male and female. So now let's say you want to check the frequency of this data here, and you want to check the frequency against this variable sex. You want to see in this data how many times M has repeated here, how many times F has repeated here. Now if you remember, in this data we have 11 females and 10 males. So let's see how do we check the frequency of this data here. So this is a command for that. So I'll read this. Proc frec data is equal to admit semicolon tables sex semicolon run semicolon. So now this will give me the frequency of admit data for the variable sex. It will tell me in admit data how many times the observations in sex variable have repeated. So I'll select this. Again is just a proc command. It will only give me the listing and HTML. I'll select and run listing and HTML. This is a frequency procedure against variable sex. F has repeated 11 times, M has repeated 10 times. 10 plus 11 is 21 because we have 21 observations in admit data. So now this is one level frequency here. As of now, we're just checking the frequency against this variable sex. Now we will do two level frequency. So I'll read this command here. Proc frec data is equal to admit semicolon tables sex by age semicolon run semicolon. So now in this command here, this will give me the frequency of admit data for the variable sex by age. It will tell me how many males, how many females are there in different age categories. It's a bifurcation of male and female against different age categories. So now this is a proc command. Again here I did not mention an out command. So it will not create any separate data. It will only give me the frequency of admit data for the variable sex by age. I'll select and run listing and HTML. So automatically when we run the two level frequency, I'm doing sex by age here, we automatically get frequency percent, row percent, column percent. Frequency means in the age group of 22 there is one female, 0 male, the frequency is 1. Percent means what is the percentage of this female here, 4.76. Row percent, in this row what is the percentage of this female, 9.09. Column percent, in this column because we have one female, 0 male, the total is 100% for this female here, and similarly for the rest as well here. So now whenever we run the two level frequency here, we automatically get all of these frequency percent, row percent, column percent. Now let's say this time we don't want to check all of these percent, row percent, column percent here. This time we only want to know the frequency of sex by age here. So let's see how do we do that. This is the command for that. So I'll read this. Proc frec data is equal to admit semicolon tables sex by age / no row no col no percent semicolon run semicolon. So now if you see, this command here is exactly the same as the previous command. The only difference now is that I've mentioned this / no row no col no percent. No row means row percent will not come. No col means column percent will not come. No percent means total percent will not come. This will only give me the frequency of admit data for the variable sex by age. So again, this is just a proc command. It will only give me in listing and HTML. Listing and HTML. This time I'm only getting the frequency of sex by age, which means in the age group of 22 there is one female, 0 male, frequency is 1. For each group of 25, 0 female, 1 male, frequency is 1. Similarly for the rest as well. So now whenever we are running this proc command, we only get listing and HTML here. We're not creating any separate data here. Now let's say this is what you want to know here. the frequency of sex by age. Now you want to create a data like this to present it to your manager. Now to create a data in a proc command, we have to specify an out command. So let's see how do we do that. This is the command for that. So I'll read this. Proc frec data is equal to admit semicolon tables sex by age forward slash out is equal to admit underscore frec no row no call no percent semicolon run semicolon. So if you see again, everything else is the same here as the previous command. The only difference now is that I want to create a data. So in a proc command to create a data, we have to specify an out command. So by mentioning this, I'm creating a data by the name admit underscore frec. Again, you can give any name. I'm just giving this name here because we're checking the frequency against admit data. And similarly here also will not get row percent, column percent, total percent. Will only get the frequency of sex by age. So I'll select and run listing and HTML. We did not change anything. We have just mentioned out command to create admit underscore frec. So I'll open this. We have here also the frequency of sex by age. Alright. So now we will move ahead. Now we will come to this last part of today's topic, which is sorting. So now for sorting the data, we use the command proc sort. And the rule says whenever we use a sort command, it has to be specified or accompanied with a by command. With a by command, you specify the variable name through which it has to be sorted. So we have this Rx data here. In Rx data, we have this product variable. Now in product variable, we have all the name of these medicines here. Now all these medicines are neither in ascending nor descending sequence here. So now you want to sort this data here. And you want to sort it by product. So let's see how do we do that. So I'll close this data. This is a command for that. So I'll read this. Proc sort data is equal to Rx semicolon by product semicolon run semicolon. Now this proc sort command, when I run this command, it will not create any listing nor HTML. It will neither create any data here. What this will do is it will just sort the data in the existing Rx data and it would sort it by product. Now whenever we run the proc sort command, the default sorting is in ascending sequence. So product will be sorted in ascending sequence here. So I'll select and run. Nothing is created here. I'll show you Rx. We have sorted by product in ascending sequence, alphabetically from small to big. Now if you want to sort it in descending, then you will have to specify that. So let's see how do we do that. This is a command for that. Proc sort data is equal to Rx semicolon by descending product semicolon run semicolon. So this time I've mentioned descending before product here. If I don't mention anything, the default sorting is always in ascending sequence. This time, because of descending here, it will sort product in descending order this time. So again, this will just sort the data in the existing Rx data. So we will overwrite this data. So I'll select and run. I'll open Rx. We have sorted product in descending order this time from big to small. So now again, this is one level sorting here. As of now, we're just doing sorting against one variable, which is product. Now we'll do two level sorting here. We have sales variable, we'll do two level sorting. So this is a command for that. So I'll read this. Proc sort data is equal to Rx semicolon by descending product sales semicolon run semicolon. So this time I've mentioned two variables here, product and sales. Now in front of product I've mentioned descending, so product will be sorted in descending order. Now in front of sales I did not specify anything. So if you don't mention anything, the default sorting is always in ascending sequence. So product will be sorted in descending, sales will be sorted in ascending sequence. I'll select and run. I'll open Rx. We have sorted product in descending order, whereas sales in ascending order from small to big. But normally companies, what they want to do is they will naturally want to check what is the highest sale that is sold the most. So automatically they will do descending for sales as well. So let's see how do we do that. Proc sort data is equal to Rx semicolon by descending product descending sales, semicolon, run, semicolon. So this time I've mentioned descending before product and before sales as well. So both will be sorted in descending sequence this time. I'll select and run. I'll open RX. We have sorted product also in descending order, sales also in descending order. For the sim rows here, this is the highest product that is sold the most. That is sorting, and that is it for your day 4 codes here. Now I'll just show you what all has to be done. So in the last class, you had been reading after day 3 class. Now if you go read this again, you'll be able to understand better because we have practically worked on it. After that, you can come to codes. You'll practice day 4 codes just like how I showed you how to practice day 1, day 2, day 3 codes. And for assignments today, you'll practice 2 assignments. All these assignments are based on what we learn in today's class. You can try them out. If you're not able to do it, no problem. You can come to the answers folder, check 2 assignment answers. All the assignment answers are here. And then finally, you can just read after day 4 class. This will give you a gist of what we're going to do in the next class. And that is it also for day 4 class. Thank you.